it is indeed acceptable to Ufer ground a subpanel along with the main panel Ufer. This practice is common and aligns with the National Electrical Code, often abbreviated as NEC. Let's delve into the requirements, advantages, and crucial considerations for implementing such a grounding system. Firstly, both the main panel and the subpanel must be situated within the same Ufer grounding system. This implies that the ground rods constituting the Ufer ground must be electrically bonded together. Secondly, the subpanel ground wire, typically a bare copper wire, must be securely connected to the Ufer ground bus within the subpanel. Thirdly, similarly, the main panel ground wire needs to be connected to the Ufer ground bus in the main panel. Now, let's explore the advantages of Ufer grounding both panels. 1. It provides a low impedance grounding path for both the main panel and the subpanel, ensuring effective dissipation of fault currents. 2. It eliminates the necessity for installing additional ground rods solely for the subpanel, streamlining the grounding setup. 3. This approach simplifies the overall grounding system, contributing to enhanced safety and reliability. It's important to note several key considerations. 1. The Ufer ground rods must be driven deep enough into the earth to reach permanently moist soil, ensuring consistent and effective grounding. 2. The Ufer ground system should undergo regular inspections and testing to verify its proper functioning and adherence to safety standards. Let's expand on the concept of a low impedance grounding path. Impedance, measured in ohms, represents the opposition to the flow of alternating current. A low impedance path allows fault currents to quickly and easily return to the source, facilitating the operation of overcurrent protection devices like circuit breakers. This rapid clearing of faults minimizes the duration of potentially dangerous conditions and reduces the risk of electrical shock or fire. Bonding the ground rods together ensures that they function as a single, unified grounding electrode system. This minimizes potential differences between the rods, preventing circulating currents and ensuring that the entire system operates at a uniform ground potential. The connection of the ground wires to the Ufer ground bus in both the main and subpanels establishes a direct and reliable grounding path for all connected equipment. This ensures that any fault currents are safely diverted to ground, protecting people and property from electrical hazards. The depth to which the Ufer ground rods must be driven is crucial for ensuring effective grounding. Permanently moist soil provides a stable and consistent grounding environment, minimizing variations in ground resistance due to changes in weather conditions. Local codes and regulations often specify the minimum depth requirements for ground rods, so it's important to consult with a qualified electrician to ensure compliance. Regular inspections and testing of the Ufer ground system are essential for maintaining its effectiveness. These inspections should include visual examination of the ground rods, connections, and grounding wires for any signs of corrosion or damage. Ground resistance testing should also be performed to verify that the system is providing adequate grounding protection. Now let's talk a bit about the importance of using a qualified electrician. Grounding systems are vital safety components of any electrical installation, so it's important to ensure that they are properly designed and installed. A qualified electrician has the knowledge, skills, and experience to perform this work safely and effectively. They can assess the specific requirements of the installation, select the appropriate grounding materials and methods, and ensure that the system complies with all applicable codes and regulations. Furthermore, they can provide ongoing maintenance and testing to ensure that the grounding system continues to function properly over time. It is good to reiterate some of the National Electrical Code requirements. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of people and property from electrical hazards. Some of the key NEC requirements related to Ufer grounding include the size and type of grounding conductors, the methods for connecting grounding conductors to ground rods and equipment, and the requirements for testing and inspecting grounding systems. Complying with the NEC requirements is essential for ensuring the safety and reliability of any electrical installation. Let's also discuss the types of equipment that benefit from Ufer grounding. Ufer grounding is particularly beneficial for sensitive electronic equipment that is susceptible to damage from voltage surges or electrical noise. This type of equipment includes computers, servers, and other data processing equipment, as well as medical equipment and industrial control systems. A properly installed Ufer grounding system can help to protect this equipment from damage and ensure its reliable operation. In addition to protecting equipment, Ufer grounding can also help to improve the overall safety of an electrical installation. By providing a low impedance path for fault currents, Ufer grounding can help to reduce the risk of electrical shock and fire. This is particularly important in locations where there is a high risk of electrical hazards, such as hospitals, schools, and industrial facilities. Grounding is a critical aspect of electrical safety, and it's important to understand the different types of grounding systems available and how they work. Ufer grounding is just one type of grounding system, but it is a very effective one, particularly in areas with high soil resistivity. By understanding the principles of Ufer grounding and how it is implemented, you can help to ensure the safety and reliability of your electrical system. Consider the environmental factors affecting grounding systems. Environmental factors can significantly impact the performance of grounding systems. Soil resistivity, moisture content, and temperature all play a role in determining the effectiveness of a grounding system. In areas with high soil resistivity, it may be necessary to use multiple ground rods or other grounding enhancements to achieve adequate grounding. Moisture content is also important, as dry soil is a poor conductor of electricity. In areas with low rainfall, it may be necessary to supplement the natural moisture content of the soil with irrigation. Temperature can also affect the performance of grounding systems, as the resistance of grounding conductors can increase at high temperatures. Selecting the right materials is crucial. The materials used in the grounding system must be able to withstand the environmental conditions to which they are exposed. Ground rods and grounding conductors should be made of corrosion-resistant materials such as copper or stainless steel. Connections between grounding conductors and ground rods or equipment should be made with UL-listed connectors that are designed for direct burial. The selection of grounding materials should also take into account the type of soil in which the grounding system will be installed. Acidic soils can corrode copper grounding conductors, so it may be necessary to use stainless steel or other corrosion-resistant materials in these applications. Now let's address the maintenance of grounding systems. Grounding systems should be inspected and tested regularly to ensure that they are functioning properly. Visual inspection should be performed to check for corrosion, damage, or loose connections. Ground resistance testing should be performed to verify that the grounding system is providing adequate grounding protection. Ground resistance testing is typically performed using a ground resistance meter, which measures the resistance between the grounding system and the earth. The measured resistance should be below a certain threshold, typically 25 ohms, to ensure that the grounding system is providing adequate protection. If the ground resistance is too high, it may be necessary to add additional ground rods or other grounding enhancements to improve the grounding performance. When inspecting grounding systems, it's also important to check for any signs of tampering or modifications. Unauthorized modifications to grounding systems can compromise their safety and effectiveness. Any modifications to a grounding system should be performed by a qualified electrician in accordance with all applicable codes and regulations. Considering surge protection is important. Surge protection devices, often abbreviated as SPD, are designed to protect electrical equipment from voltage surges caused by lightning strikes or other transient events. SPD should be installed at the main electrical panel and its subpanels to provide comprehensive surge protection. SPD work by diverting surge currents to ground, preventing them from damaging sensitive electronic equipment. The effectiveness of SPD depends on the quality of the grounding system. A well-designed and properly installed grounding system provides a low impedance path for surge currents, allowing the SPD to quickly and effectively divert the surge energy to ground. In addition to SPD, other surge protection measures can be implemented to further protect electrical equipment. These measures include using surge suppressors on individual electronic devices and installing lightning rods on buildings. Lightning rods provide a direct path for lightning strikes to ground, preventing them from damaging the building or its contents. When selecting surge protection devices, it's important to choose devices that are UL listed and that are rated for the voltage and current requirements of the electrical system. Surge protection devices should also be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. To reiterate, the use of qualified personnel, electrical work, including the installation and maintenance of grounding systems, should only be performed by qualified electricians. Qualified electricians have the knowledge, skills, and experience to perform this work safely and effectively. They are familiar with all applicable codes and regulations, and they have the proper tools and equipment to perform the work correctly. Attempting to perform electrical work without the proper training and experience can be dangerous and can result in serious injury or even death. It's always best to leave electrical work to the professionals. It is important to understand the importance of documentation. Proper documentation is essential for ensuring the safety and reliability of electrical systems. Documentation should include detailed drawings of the electrical system, including the location of all grounding components, as well as records of all inspections and tests. This documentation should be kept in a safe and accessible location so that it can be easily referenced when needed. Documentation is also important for troubleshooting electrical problems. When a problem occurs, the documentation can be used to trace the path of the electrical current and identify the source of the problem. This can save time and effort and can help to prevent further damage to the electrical system. Furthermore, documentation is required by many building codes and regulations. These codes and regulations are designed to ensure the safety of buildings and their occupants. Complying with these codes and regulations is essential for obtaining building permits and for avoiding costly fines. Consider the impact of future expansion. When designing an electrical system, it's important to consider the potential for future expansion. The grounding system should be designed to accommodate any future additions to the electrical system. This may require the installation of additional ground rods or other grounding enhancement. It's also important to consider the location of future equipment and the potential impact on the grounding system. For example, if new equipment will be located in an area with high soil resistivity, it may be necessary to install additional ground rods in that area. Planning for future expansion can help to prevent costly and time-consuming modifications to the grounding system in the future. Furthermore, planning for future expansion can help to ensure the safety and reliability of the electrical system as it grows. Remember that using the correct tools and equipment is vital. Electrical work requires the use of specialized tools and equipment. These tools and equipment are designed to be safe and effective when used properly. Using the wrong tools or equipment can be dangerous and can result in serious injury or even death. It's important to use only UL-listed tools and equipment and to follow the manufacturer's instructions carefully. Some of the essential tools and equipment for electrical work include voltage testers, wire strippers, pliers, screwdrivers, and multimeters. Voltage testers are used to verify that electrical circuits are energized before working on them. Wire strippers are used to remove insulation from electrical wires without damaging the wires themselves. Pliers are used to grip and manipulate electrical wires and components. Screwdrivers are used to tighten and loosen screws. Multimeters are used to measure voltage, current, and resistance in electrical circuits. Regular training and education are essential for staying up to date on the latest electrical codes and regulations, as well as the latest technologies and best practices. The electrical codes and regulations are constantly evolving to reflect new technologies and to address emerging safety concerns. It's important to stay informed about these changes so that you can ensure that your electrical work is safe and compliant. There are many resources available for electrical training and education, including trade schools, community colleges, and online courses. These resources can provide you with the knowledge and skills you need to perform electrical work safely and effectively. In addition to formal training and education, it's also important to stay informed about the latest industry news and developments. This can be done by subscribing to industry publications, attending industry conferences, and networking with other electrical professionals. Finally, remember the importance of safety first. Electrical work can be dangerous, but it can be performed safely if you follow the proper safety precautions. Always to energize electrical circuits before working on them. Use the proper tools and equipment for the job. Wear appropriate personal protective equipment, such as safety glasses and gloves. Be aware of your surroundings and avoid distractions. Follow all applicable codes and regulations. By following these safety precautions, you can help to prevent accidents and injuries. Safety should always be your top priority when working with electricity. This is a good overview of Ufer grounding and how it can be used to ground subpanels and main panels together. Remember that it's always best to consult with a qualified electrician to ensure that your electrical system is safe and compliant with all applicable codes and regulations.